Despite steady advances in input and interaction techniques, mouse pointing remains a dominant form of interaction with computers. However, when making these pointing movements, what is usually most important lies only at the end of a movement. If we could create a means of knowing the location of endpoints in advance, we could increase the efficiency of mouse pointing with techniques such as target expansion or gravity wells. We present kinematic template matching, which treats the unfolding velocity profile of a pointing movement as a 2D stroke gesture and uses template matching to predict the endpoint based on prior observed movements. Here you can see a candidate pointing movement being compared to a small library of past pointing movements. Notice that the most similar velocity profile to the candidates is selected to predict with. Our approach is user-specific, target agnostic, and is both easier to implement and more accurate than prior techniques. We found that on average, kinematic template matching is able to predict within 83 pixels of the true endpoint when 50% of the movement has been completed, 48 pixels at 75%, and within 39 pixels at 90% using 1,000 templates per participant. This illustration shows predicted endpoints as red dots appearing near the intended target. Note that the prediction algorithm has no idea that there is a target here, as our approach is entirely target agnostic. To the best of our knowledge, our work is the first to conceive of time series velocity profiles as stroke gestures in 2D space, and to utilize stroke gesture template matching as a means of predicting the endpoints of aimed pointing movements.